Okay, and we're live, and we'll see if anybody else says hi as they start logging in.
And you might mention that they need to go to the left menu. Isn't that where they open the chat box?
Well, you would do that because you're live in the session.
Oh, I see.
And, you know, I have never participated in one of these events where I was just a static viewer.
Uh-huh.
So I really don't know what that interface looks like. And I really should have had that set up and just like swap places with a friend or something. Said, here, jump on my computer for a little bit and start talking. I want to go over here and look at this.
Yeah.
I should have done that.
Well,
But now the whole system's changing, so we have to adapt.
I opened the group chat, but I don't know if how many others can see this. Let me take a look here.
See, I have a Q&A tab that I press, and that opens up there. So when any questions come in, I see it there from the chat.
Well, it might just be the three of us.
Well, I do see somebody said they were going to attend the event. I just got that update. So they might be logging in too. Well, while everybody is logging in and getting ready, I just want to introduce everybody to this is Hanging with Education. It's a weekly event where every Wednesday at 7 p.m. Eastern Standard Time, we gather together as educators around the country just to talk shop, share notes, share little tricks and things we have had some success with. I always encourage people to join me live so we can have discussions on air and ask questions easier. However, some of you will be watching through the video where you just have text. You're encouraged to go ahead and type your questions into the chat, and then I'll see those questions. It may take a minute or two for me to get to those, but I do get to those during the conversations. Tonight I'm joined by Lisi, and you're out in Colorado, correct, Lisi?
That's correct.
And I see
Christine Bryan just joined.
I just saw that. Hello, Christine. And we're going to be playing with Scratch today. So if you have not gone to the Scratch site, on the Hanging with Education event page, I do have a link to the MIT Scratch site. If you don't have that, I'm going to do a screen share here where I can share with you. The website where all of these activities are hosted is 5squared.us. So it's just the number 5 squared, all one word, .us. And if you click on the Hanging with Education tab, you'll come down and where it says upcoming sessions, you can see the event link for today. And down below that, you'll see the archive sections. Last week, we introduced a bunch of tools that could be used to teach adults programming. And there was a lot of interest in exploring Scratch. So if you don't have a link to Scratch, you can go to 5squared.us and click on that second tab. And down here, you can click on the link that says Scratch and. I don't know why it says and still. When you do that, you should get to a site that looks like this. And if you've reached this point, you're ready to start. I want to give people a few moments just to check in on chat if they're having difficulties. Or if you're not there, please let us know, and we can try to help get you there. Lisi, were you able to get there?
Yes, I already had Scratch on my computer, and I noticed that you can either download it to your computer and work with it offline, or if you click on this site, it opens the online program. But another site, and I wish I had it, I couldn't find the download on this page, but there's another page where you can download it onto your own computer and play with it to your heart's content offline.
They used to have a download, and it used to be pushed as a download. And one of the challenges were a lot of teachers only had like a mobile cart. And it was very difficult for students to save things in the right place and transfer it from computer to computer. So MIT went really with a cloud-based system, and they actually patch into Google. When you sign in, they ask you for a Google account because uses the Google Drive as a storage medium behind the scenes, and they code it so you don't have to go looking for it. And it's not a mess at all. It's very slick. And you can do it from any device. So handheld or phone or anything, you can still integrate. Although phones are pretty hard with Scratch. It's really hard to see that small.
Yeah.
All right, let's assume everybody has got to Scratch site. I'm on the web version, and you can just click over here where it says try it out. But before we do that, I just want to highlight some of the areas up top, particularly the help screen. A lot of teachers are concerned that I don't know anything about programming. Well, I just wanted to highlight that the help screen here, I'm going to click on it to bring you there, gives you so much to get started with. In particular, I have found these Scratch cards to be invaluable, especially with younger learners, although I found adults appreciate having these colorful cards as well. The idea is you print them out, and I'll show you one of the cards. It's going to load a PDF here, so this may take a moment. But you print them out, and you can print them in color or black and white. I've done both. And you fold the card in half. So you would fold it right where my cursor is. And on one side, you would see graphically what's going to be happening. And on the other side, you would have the step-by-step instructions. You can set up stations where one of these cards is at each station. And then you could have learners jump from station to station. Or you could have three students at a station. They all learn it, and one of them stays behind to teach two other people. That's called the stay and stray method. And you can end up teaching all of these skills very quickly with these cards. And these are nice, easy, basic skills that people would like to do. You know, here it's getting a character to say something inside a code. Another one down here is making something glide across the screen instead of just zipping right across. So a lot of these are things that people would want. How do I follow the mouse cursor? So this collection of cards I've often worked with learners on in one class to get them competent with all of these skills. And then I offer them a challenge and say, okay, I'd like to make a program that does something like this. Use all the skills you've learned in whatever field you like and go. And the students love showing off their work at the end of that. And they have these cards for reference. Let me back up. And you'll see that was just the starter cards. There are other cards that they have, other card sets they have available, and they keep adding to this. So they do a wonderful job of supporting teachers who may have never taught programming before. I would also like to highlight the Getting Started guide. This is a PDF. You probably don't want to print this out because it's pretty hefty. But if you wanted to have a whole curriculum of how you would start, this is a wonderful curriculum to use. It brings students through 3 phases. One is animated storytelling. Then they also bring you through game design, and then how to share your game and get it working with community. So there's projects and step-by-steps and everything else inside the guide. I think it's like 200 pages, but that's useful as well. So all that, again, is under help, and this whole tool and everything else is free. So that's all cool. So let's go back. I'm going to click on Try It Out, and we're going to get playing. Now, depending on your system, it may take a little bit to load up. I mentioned there was the help available from the site, but you'll see on my right-hand side, they already have an embedded tutorial you can go through. And they get a little cat moving, plus a person changing screens on a background. And they have a pretty nice tutorial here. I will leave that for you to explore at another time. So what I'm going to do is I'm going to hit the little X that's above that tutorial. And what that'll do is close that tutorial so I don't see it. If I need to see it again, I can just click the little question mark on the right-hand side. That'll pull up that tutorial screen again. So I encourage you to do that at a different time. I'd like to give you a different experience, something that you may not see in the normal material, because you can always go more material. We have this cat out here, and I'm just clicking with my mouse and dragging it around. And I always ask learners to see if anything changes when they do this, just to get them start to explore what's going on in the screen. And this is like a Where is Waldo? What's actually changing on the screen? Lisa, do you see anything that's changing on your screen when you move?
The go-to.
Okay, yeah, go to that actual box right in here is changing. Some students will also point it down here in the coordinate grid. Anything else changing? Besides the glide, go to. Some students, again, trying to look outside the boxes, notice way over here in the right-hand corner that it says the X and Y coordinate for that image. And as I move it around, it changes up there.
And I don't know if that's a shadow that moves with it, or if that's just when you move the cat itself develops a shadow.
Isn't that neat? Yeah, that's just to let you know you've picked it up. For those of you old enough to remember Colorforms, I feel very much like I'm moving Colorforms around, especially once I set up a background. This is called the Sprite, and the Sprite has a little eye next to it. When you click on it, you can get information about the Sprite. You can rename it. You know, naming something Sprite 1 is kind of silly. So I already start with the programming convention of having a decent name that describes your object. So I'm just going to type in cat. And again, the way I got there was I clicked the little eye in the top left-hand corner of the icon, and I just typed in cat. We're going to come back to this screen in a little bit, but I just wanted to show you that there is more information here about the specific Sprite. In the middle of the screen, this is kind of your toolbox. You have tons and tons of tools. Right now, motion is selected, and you'll see, I'll scroll through the list here, and you can do so as well. There are a number of different options in here, and they're written mostly in English. There's a little bit of geekery thrown in here and there, but for the most part, you could read that in English and guess what it might do. Typically, you can take something like a move 10 steps and just drag it out here. This is your coding zone, where you can sit there and put puzzle pieces out there and see what they do. So if I double click on this, you can see my cat moves. I'll double click on it a few more times. Every time I double click on it, it executes the command. So if I want to see what something does, I simply double click on it. So I'll turn this 15 degrees. I'll turn it back 15 degrees. I can point it in the direction of 90. Well, 90 is already facing right, and negative 90 is left, up or down. I can have it face up. What's that do? Well, when I change it to up, nothing changed. I had just changed the setting of what this direction will do. I just changed it to up. I didn't actually execute it. To execute it, I have to double click on it, and you can see that now the cat is facing up. And I can click on the direction over here again and face it back to right and double click on it again, and that gets it facing the direction I want. Now, if I've moved commands out here and I don't want them anymore, I have a number of ways I can trash those. I think the easiest way is just pick up the command, drag it over here to some white space in your toolbar, just drop it. That destroys it. So I can have any number of these out here I want. Just bring them over to the white space here and drop it. You'll also notice that they click together. When you move them close together, you see a white highlight. That clicks them together, so it will do 2 actions or more, and you can string a whole series of actions together. By clicking on the bottom of this, it tears away an instruction. But if you click on the top one, that grabs the whole stack. So you can think of whatever's on top is going to be like a handle, and you can click on that to move the whole stack of code. But if you click on something towards the bottom, that breaks it away from the rest of the code. So if I had a number of other commands in here, and I clicked on this one right here, it's going to break right above wherever I hold it. If I grab this one, it breaks right above. So wherever you click, you're causing a break, unless you're at the very top, which that is just your handle to drag around. So that gets confusing for people, the way those are linked together. The looks menu, again, I'm in the middle. I just clicked on the purple looks. This is for things like text on the screen, whether you're going to hide things on the screen or show them. We'll talk about costumes. That's how we do animations. We can change colors. We can do all kinds of cool stuff in here. And then we'll go to sounds. Believe it or not, you can record your own sounds. They do have a pretty extensive MIDI library that they include for free, but you can actually record your own sounds, and that's always fun. I have some students who are very dramatic when they start making their own sounds, especially if they're doing like a shoot 'em up game. They have some very interesting sound effects when things die. Excuse me. Under events, we can start the program. Excuse me, I got something in my throat.
Take your time, that's okay.
All right, there, I think I'm back to breathing again. That's good. You can start your program when a flag is clicked. That's kind of okay, tell the computer that I'd like to do something whenever somebody hits the green flag or when the program is actually loaded from a website. So everything underneath this particular event will run when the green flag is clicked. In contrast, this event says whenever the space bar is pressed. Later on, we're going to mess around with that. We're going to see that we can put any key we want in there and have each key on our keyboard do something different in our program. So with these basics, and we'll go through some of the other menus in a minute. I know people get bored just watching run-throughs of menus. So let's throw a challenge out there. I would like to have you have the cat walk across the screen in a way where he doesn't just zip across the screen. So you want him to take at least, let's say at least 4 moves to reach the edge of the screen. How would you do that? So you can play around. I'll give you a hint. You'll be using the move tools. There's a bunch of different ways to do that, and each person may have a different solution. So I'll give people a few minutes to play around with that.
Well, I just moved 10 steps and kept double clicking.
Okay, that's one way. Now, if you get tired of moving only 10 steps, you can click inside of that and change that to maybe like 20 steps. I don't know how that's going to work. 1, 2, 3, 4. So 20 steps might be a little too small. So maybe I'm going to jack that up to, I don't know, 80 steps. All right, 3 steps I'm pretty much off. So 80 was quite high. So let me bring that down a little. So a lot of this is guess and check. And this immediately puts people at ease that, okay, I don't have to have it completely perfect to start playing with things. And it also introduces a very important programming aspect. You will make mistakes in programming. I've worked with so many different programmers and taught so many people to program. They all want to have it right. They're all afraid of getting it wrong. Well, I often learn more about my programming by watching incorrect code or code that's not doing what's intended than I ever did reading a book or doing a program perfectly. Another thing people might do is they may string together, oh, I'm going to take this move 60, and I'm just going to right-click on it and hit duplicate. Now, those of you who have a Mac with only a single click, I believe it's Command and click. Or it might be Control now. I get confused. It always changes on me. But if you hit duplicate, you now get a copy of that block that you can put in there. So if I wanted to move 4 steps, I could duplicate that 4 times. And now when I click the top one, it runs it runs completely off the screen. So I double click on it and it just jumps off the screen. Now what I notice about this solution versus Lisi's, with Lisi's solution, I can see it 1, 2, 3, 4. I can see it take 4 steps to go off the screen. But Ed's solution, where I put 4 steps all together, this one doesn't do that so well. It just kind of zips right across the screen. So this is where we start talking about the computer speed and how fast it really processes everything. And it turns out it's nanoseconds, and we can't count nanoseconds, not easily. So we might want to control things a little bit here. By control, we hit on controls, we can find something that says wait. So now I can take a wait block and just shove that in there. 1 second might be a little bit long, but let's just try it just for the sake of illustration so you can see how long a second is. What is it? Murphy's Law says a minute depends on which side of the bathroom door you're on. So let's check out this 1 second wait. I'm going to double click it. It moves once, twice. Well, 1 second's not too bad. So the wait command in there, you may have to slow the computer down a little bit and say, whoa, our eyes need to catch up to you. Now, if I come up to the top and I click the flag, nothing happens in my program. It doesn't run at all. Well, that's because I just have blocks of code floating out here. And I need to actually give an event to say when the flag is clicked. So now I come back over here, and now if I hit the flag, it executes the code. Because I have all these blocks underneath the when the flag is clicked. Now you'll notice that after every time the program runs, I have to set the cat back here to the middle. Well, that's kind of annoying. So look through your motion again and see if there's a way we might reset that.
Good. Just go to X or Y.
Okay, so we're going to use the go to. That's right here. Where would I put that, Lisa?
A certain number of steps.
Yeah, I'm going to put it right back at 0, 0, just to see where 0, 0 is on the screen. Is it in the middle? Is it in the top left? Is it in the bottom left? I mean, it could be all over the place. If I'm used to math, maybe this is quadrant 1 and 0, 0 is in the bottom left. So this will let me know where 0, 0 is. Where would I put this in my block of code, Lisa? Do you have an idea where I might put that in there?
At the end of every sequence.
Okay, so like right down here at the bottom?
Yeah.
Or would I put it after every move?
If you put it after every move, it'll go back there every move.
Yeah, it will every time. So let's give this a try and see what happens. And I always encourage students to guess, give me a reason, and then we'll see what happens. Well, that didn't quite do what we wanted to. It did go back.
Yeah.
But I didn't really see that last step. Let's run it again. 1, 2, 3. I'm not seeing the 4th step. Any ideas why that might be?
Well, I know that I have the offline. I'm working offline with it, and when I click on my series, nothing happens. I have to click, click, click to make it go move 60, move 60, move 60.
Are you using the when flag clicked?
Okay, that's what I'm not putting up there.
Yep. Yeah, you'll have to have that on there. And again, if we were in a face-to-face setting, I would be checking with students, and we'd actually have programming partners where our partner always double checks us. You know, after I get it running, I show my partner and I say, you know, is yours doing the same as mine? Let me check yours out. And we develop that safety of turning to each other as learners and as teachers. And that really helps a lot because you're starting to build that programming collaboration. So, Lisa, I can now understand how the go to X works perfectly well when you have to click on each one of these. But when it's all under one umbrella or one event, you'll see that it executes this last move and immediately moves it back to 0, 0. So I'd never get to see that last move. So we do want it to move to 0, 0, but I'm going to move it right at the beginning. This is often called the initialization. I'm trying to tell the computer how I want things to look when I start the program. Then I get into the block of codes that actually change things. So now when I click my flag, cat automatically starts in the center, and he ends up moving his 4th space off the screen. So now if I hit start again, he automatically jumps right back because the first line of text says go to X and go to Y. I see a lot of learners, they have the right command, but they put it in the wrong place, and they're like, why isn't this working? So placement does matter. Let me just check the Q&A here just to see if anybody's added any questions here. Jeff has joined us. Sprites are in some cases called billboards. Before the 3D accelerator was made, games used to be run in software mode and were made mostly of sprites. Where Tomb Raider was made, developers realized 3D worlds couldn't run effectively as software, and the rest is history. LOL. Yeah, Jeff, I grew up in that age of tile-based graphics. In fact, one of the most popular video games to start a whole genre of video gaming, the multiplayer online dungeon, was Ultima Online. And that was a form of tile-based games that was massive. I mean, there was hundreds of thousands of people playing that game all at the same time. And it was all tiles just moving across the screen in 2D. Highly productive and got a lot of people turned on to the idea of gaming. And it helped start an industry. That's where WoW came from. That's where EverQuest, all these huge multiplayer games that make billions of dollars now, they all started from that concept. And then they built off of that. So when learners see that this is just a gateway, they start getting excited. I'd like to have it so that when this cat, well, actually, let's make a change here. I'm going to move everything off here. I'm going to move that go-to right back to when click. So I always go back to the center when I start my program. I want to just have it move and wait repeatedly over and over and over again. So I'm going to move the rest of my block out of here. I only need the move and the wait. I'm going to go to control, and under control, I have a whole bunch of things. I'm going to repeat forever. Jeff is sharing that they're using the new Unity engine, but they're thinking of moving to the Unreal engine. I know the Unity engine, for those of you who are not aware of it, when we talk about engines, we're talking about programming platforms that have some built-in components so that a programmer doesn't have to spend a lot of time nitpicking over how do I code this? There's already a procedure set into it. And they have different methods for storing things and retrieving things. So when you hear someone talk about a Unity engine or an Unreal engine, think of it as they're both different types of cars. They can get you moving. One of them might be a standard. One of them might be automatic. One of them might have air conditioning. The other one has power windows. So they all have different features in them. Unity, by the way, is a really nice system to get started, but it does get a little clunky the bigger your activity gets, unless you're really good at scaling your coding down efficiently. While I was talking, I did take the forever loop, and I wrapped it around. As soon as I move it over some code, it tries to hug the code. And once it's hugged, I can now grab that forever loop and put it in someplace. So now when I run my program, it's going to go to 0, 0. It's going to loop forever. It's going to move 60. I'm going to change that down to 30, just so we can see it move a little bit slower. And then I'll ask students, what do you think is going to happen? This predictive aspect of programming is very important. It's kind of like a hypothesis in science. You can surely mix chemicals together, but if you don't take a moment to try to think about what's going to happen, you really lose out on some of the assessment of the data you see after it runs. So I would guess that this thing's going to run until it hits the wall and we're all good. Program ends when it hits the wall. So let's see what happens. And students may have different conjectures. And we'd have people support their, why do you think it's going to stop? So here it goes. Here he goes. Oh, I can just see a bit of the tail. Notice how the green flag is still lit. The program is not stopping. So I was incorrect in my assessment. I mean, the cat stopped. Matter of fact, I can drag him out here. He still wants to go there. It's like, no, stay. This is like a real cat. I can tell it where to go, and it still climbs to climb back after the tuna fish can. But that green flag just keeps running. This program always runs. And that's because of that forever loop. Now, they're very nice in leaving the graphics on the screen, so I can at least grab a little piece of it and pull it back out. I'm going to click the stop sign here, and that stops that forever loop, so I can bring it right back out. So I now have it moving. I have it hitting a wall. I'd like to have it bounce off that wall and go towards the other wall. So if we look through, we need to find something that says bounce. So if we start looking through motion, see if there's anything in bounce there. Oh, there is one. I thought it was under sensing. See, I haven't memorized all these palettes, but it is under motion. If you see here, it says if on edge, bounce. So it automatically checks for us. It does a logical operation. If it's on the edge, bounce it. That's cool. But now where do I put this thing?
Under wait 1 second.
Okay, let's try that. See how that works out. It's running. And again, for testing purposes, I probably, oh, hey, bounce. Wait a second. Hey, I know cats can go upside down a little bit, but that's a little ridiculous.
It bounced upside down.
Oh, then it bounces back. So this is pretty interesting. The orientation of my figure flips. So if you think about where the feet are, if we tell it to bounce and it's going the other way, the feet would still be in the same position, so they're walking on the ceiling. I can change that, and I need to change that in this particular example. I'm going to hit my stop symbol here just to stop my cat from climbing all over the place. I need to bring you back to the sprite. And on that little eye, there's an important setting we have to change on that sprite. Where it says rotation style, it currently has that curly Q thing. We want it to go only horizontal. So whenever it's asked to rotate, instead of rotating, it's really going to be a flip. And this is a nitpicky thing. It's something that you have to experience. If you never experienced it, this is where having programming people you can ask questions to is really helpful. So having a social network you can reach out to and say, hey, it's doing this. What might I try? Your social network can help you out with that. So now when it hits the edge, it should just flip around, and it does. And that movement, he's a little slow here. I got to jack him up a little bit to get some movement out of him. And I just wanted to make sure it bounces off of both walls correctly. It seems to be bouncing well. So it's just a little awareness that what we expect isn't something that the computer expects. Computer doesn't speak English, nor does it think like us. When we talk about English as a second language, the computer is very, very slow in picking up any English. It doesn't have any ability to decode what we think we tell it to do. It only runs on very finite commands. So we've got it moving, we got it bouncing, but when it moves, this is really a lame movement. I mean, it looks like he's doing a shuffle without even moving his feet. So I want to get those feet moving. So now it's time to introduce costumes. Scratch comes with a number of sprites that have different costumes. And in the middle panel, you'll see that middle tab that says costumes. And you'll see that I have 2 costumes. And if I click between them, you can see it almost makes a little sort of animation. So I would like to be able to change those costumes back and forth. That's kind of cool. So let's go over to scripts and see if we can do that. Now, costumes, that's how it looks. So I'm going to guess it's under looks. Let's see if it's in there. Something about costumes. Oh, right here. I've got switch to costume, so I can change it to a single costume setting, either costume 1 or costume 2. Or I could just say next costume. Ooh, when I double click on it, I can see what happens.
Yeah, that's cool.
Ooh, okay. Let me put that in there. After we move, oh, should we do it before? Let's do it before we check to see if we hit the edge. And let's see if we walk. Oh, he's walking, but it's a little staggered here. I want a more natural pace. So I want to change maybe my weight so there's less of a delay between its movements. So I'm going to put that to maybe 0.25. This gets people into decimals and fractions. And we could talk about how is it that this thing's going to move faster if we're getting smaller values in here. And it kind of gets into the idea of a double negative because the weight is telling you to stop for a period of time. So if you're waiting for smaller amounts of times, the thing will actually move faster. That's not working the way I want it to. Better. So it is better. I'm going to try moving my steps down. I'm going to move it back to 10. And I'm going to change my weight even lower. I'm going to put it to like 0.1. just to see how that works. That's probably closer to what I was working at, but I have seen some students now turn into really obsessive animators. They want that smooth and polished with a nice glow in the teeth as it's smiling, and that points out to me that these people need to go into graphic design. They need to go into animation. When they have a passion that that tight of getting this to look good, I'm a functional programmer. I'm like, hey, it's moving. He looks like he's sort of walking close enough for me. Maybe later in the game when he gets a power up or something, he can move a little smoother. Now, it'd be really nice if I could get him to blink or something every once in a while. Because right now, that little frozen face, that mouth and everything else, we don't see any teeth. It kind of creeps me out a little bit. So I'm going to go over the costumes, and I'm going to click on one of the costumes. It really doesn't matter which one. And I'd like to zoom right in on this picture. Now, the zoom settings are down in the lower right-hand corner. And if I click on the plus symbol, I can zoom right in on him. That's nice and big. So I zoomed it into 400%. And now we are in what's called vector mode. There's a difference between bitmaps and vectors. Vectors, think of them as transparencies. If I draw a line, say I draw this line right here, and then I click a pointer tool, I can click on that line, and it is a transparency over everything I've drawn. That's vectors. They're like geometric shapes that become objects once you're done drawing them. In contrast, if I convert this to a bitmap, every point of light on this screen is like the old light brights. They're all points of color. It's like painting. Once you make a mistake in painting, just like what Bob Ross used to say, there are no accidents, they're just happy little trees. So you're going to have to cover over those pigments with other pigments. So you can't just pick up and move a pigment around. So bitmap is really nice if you need to do something like painting where you want to blend colors together and have a smoother color transition. I like vector because I can draw it, and if I make a mistake, I can move it around afterwards. I can resize it. I can rotate it. I can do all the stuff I'm used to doing if I'm used to Publisher, PowerPoint, or any kind of presentation software. These tools are very similar. So what I'd like to do, I'm going to just hit backspace on my computer to delete that. I'd like to get it so that, what are we going to do? Blink the eyes? Maybe we could blink the eyes. Oh, how about the whiskers? Let's get the whiskers to move. That might be easier. So when I click on the cat, I get the whole cat. Not getting, just one part of it. So I may have to delete parts of the cat, or I can click on this thing that says reshape. Reshape, if I click on the whiskers, for instance, I'll see that I get 3 points on that whisker. I'll get the end, the middle, and the origin. So maybe on this one, I want to move this whisker up here a little bit. And maybe I want to move this whisker down here. I got to click on that bottom one. And I'm just going to move that middle down a little. And I'm going to get the whiskers on the other side modified. And I'm simply just using the resize, the reshape tool to reshape some of the vectors that have already been drawn. This makes it very easy to animate things if you've designed your image well. Now, in this case, the whiskers were designed well. I don't know about the arms. I mean, if I click on the arms, I got a lot of parts there. Still, there's only 1, 2, 3, 4, 5, 6, 7 different nodes. They call these nodes that I'd have to move. But if any of you try this, you can see, wait a second, holy mackerel. This is like I'm watching Terminator and the guy's just going to lance someone's head. This is not what I was intending. I wanted to move the whole arm. So that makes it a little more challenging to move the pieces because the nodes really distort the picture pretty quickly. But for things like whiskers and stuff, that's pretty easy to do. So now I'm going to go back and look at my script. I'm going to run it again, and I can see that the whiskers are flapping up and down as he runs. Actually, it looks like he has a duck on the side of his cheek squawking. Okay, maybe not the animation I wanted, but I did want to show you how you can make alterations to the images. Well, maybe that's not enough. Maybe I just want to make my whole brand new sprite. Before I do that, some of us don't get as courageous to start drawing on our own. We can choose a sprite from the library, and you'll be surprised there's an awful lot of choices in here. So when I choose that, there's some categories I can choose from. You know, from fantasy, we get the dragons, and he does breathe fire, so that's kind of cool. You know, we had ghosts, we had knights. Under animals, we have all kinds of animals, like a dog here, beetles, bats, and some of these things do have animations that you would expect. A fish, I think, has little bubbles that come up. A bat would flap its wings. I could even use letters. Some people, and all these, many of these have costumes, so we can make people dance and things like that. And there's transportation items. So you can add in other library items, and you can also add in by type. I mentioned bitmap. So all of these images right now that I'm showing you are bitmap transportations. I click all, I can see all the bitmap options. If I click on vector, I get to see all the options under vector. So if you want to have your learners working just with vector, you might want to have them click that button vector just to make it easier for them to change some of the settings. You can go ahead and try that. I'm not going to do that. I'm going to be a little bit more adventurous. I want to draw my own. In fact, I want to make a racing car. So I'm going to take my cat. I'm done with him. I'm going to right-click on that sprite, and I'm going to say delete. Now, I've got nothing out there. I have no sprites. So I'm going to come over here and click on the paintbrush that says Paint New Sprite. When I paint it, I get a bitmap editor. So this is now in bitmap mode. I could convert that over to vector, but I just want to show you how this can make some pretty interesting scenarios. I'm going to choose a color other than black. In this case, I'll choose blue. And I'm going to choose, let's do a square, a rectangle-ish. So I'm going to just draw a rectangle type shape. And that looks pretty good. I want to fill that. So let's fill that with blue. Oh, I filled it with white. I wanted to fill it with blue. Hold on. Change that color. I did that by hitting the fill canister. It already had blue there by default, and I clicked in the middle. So I have my blue. I'm going to look at this as a car from the top of the car, and I'm going to put some big old tires on that. So I'm going to choose black, and I want the thickness to be pretty thick here. So I'm going to make some nice big old tires. So I chose the brush. Well, that's a little too big for tires, especially if we're doing a top-down view. Oh, that might work. I'm going to put that there. Another tire here. Obviously, I'm drawing in perspective that many elementary students would have, where the tires are flat circles on the side. So if you're an art teacher, I do apologize. We're just making a video game here. And it would be helpful for me to know where the front of the vehicle is. So vehicles often have hoods in the front. So let me draw a rectangle. Oh, that's not where I want it. So I will delete that. I want it over here more. I can drag that down. And then I can drag that out. All right, so there's my car that looks kind of like a truck that has its wheels hanging out on the side like a hovercraft. And students may get really inventive here. They're going to put some headlights, which of course are, messed up as the tires. And this one's just going to have a single headlight. I'll make it smaller, because the other headlight got blown out. So now here's my image. I want to get it moving. So I come back to scripts, and I'm going to put out an event, and I want this time when space key is pressed. But instead of space, I want to use the arrow keys on my computer. So I'm going to choose, instead of space, I'm going to choose the up arrow. So when the up arrow is pressed, I want this thing to move. I want it to point in a certain direction first, And with students, I would actually be asking them to create a car that moves and then gauge the stresses that students have, and then offer hints as I see stresses getting to a negative point. You want to have positive stress, but you don't want that stress to get so steep that they start not enjoying the experience. And I'm going to have move 10. That'll work fine. Let me just try it. I'll press up arrow. Wait a second. My card turned the wrong way.
Turned the wrong way.
What's going on with that? Oh, remember we had to make that setting before? Let's see if that changes. Let's change this. Let's see if that does this. I'm going to press up. All right. At least it seems to be working well for up. Now, I'd like to do this code for down, left, and right. So I'm going to right-click on the top of the code I made and hit duplicate. And this will not connect, by the way. These will be 4 separate pieces of code. And I'm going to change the down arrow, and I'm going to change the down direction. Now, notice I have to change it in 2 places. Students get all excited and they want to see things run. They forget to take the time to make sure all the settings are changed. And then they get frustrated with, why isn't it working? I want to right arrow, and I want to move right. And then I have to do it again, finally, for left arrow and left. Left arrow and left. So now I should be able to grab my keyboard. I'm going to go left first, and I'll go right. Wait a second. First time I press left and right, something funky's going on. I'm going to press left right now. And look what's happening to my shape. The headlight is swapping sides.
It turned upside down. It flipped.
It flipped it. So whenever I hit left or right for the first time, it flips it first. So it's almost like it's not centered. Let me try down. Here's down, and I press up. Down and up seems okay. This left and right thing is bugging me. So I want to go back in the costume, and I want to check something. I know what I did wrong now. In costume, in the top right-hand corner, there's this set costume center. Let's take a look. My center is way back here in the right rear passenger side. Instead, I want the center to be like right, I don't know, about here. So now when I ask it to turn left and right, whoops, I have to move it there. There. That's about the center I want. And then I can click off of that and go back to scripts. Now let's see how that moves. Well, it's still switching sides, but it's not quite as obvious what it's doing. So a challenge I'd put out to students is, how do I get that so that, also notice when I go left, the car is not facing left. It's not facing right when I go right. When it's going down, it's not turning around and facing down. So I've got a lot of problems here. And I would ask students to troubleshoot this and try to figure out what's going on. So again, you get students started on a path with the intent of what you want to do, and you demonstrate and illustrate what really happens in programming. We want this car to do certain things. Let's write that down. What is it supposed to do? Here's what we're trying to do and why we think it should work. I have it pointed in the down direction. Why is the graphic not turning around? Well, student might say, possibly it had to do with that rotational thing. Let's go back and try the rotational thing and see how that changes things. So now when I click the down one, that doesn't seem to be facing down. Up, well, that faces left. Right, well, that works that way. Oh, when I go left, it flips upside down. So as a student, I got to figure out, well, there's a lot of things going wrong with this flipping thing. What's this little dot do? I don't know. Let's try it. So again, that idea of experimentation. Well, that looks good. All right, the down arrow at least isn't flipping it. And then, well, my right arrow seems to work okay. Oh, I'm not getting that flipping left and right thing. My headlight, that fixed my headlight. So again, this discovery, you really want to instill right off the bat with programming because students really need that sense of discovery. I'm going to leave that as a mystery for you to explore later because I want to show you how you can animate this a little step further. I'm going to change my controls so that up arrow increases my, you know what, that's going to be too much of a jump for the 10 minutes we have left. What I wanted to do, and I put this challenge out to you, you guys can send me copies and I'll post it up to links or to the Hanging with Education site. I can send links to everybody for what you create. But I'd like you to get it so that up arrow increases the speed of the vehicle. The left and right turns it. So left and right is a little easier. You know, so when it's left, when it's right, I want to turn 15 degrees. And maybe I have to tweak the degrees a little bit. But right now, if I turn it this way, that way, it's not turning. Let me go back to the rotational settings. So now as I turn it, all right, that's working fine. And then I want, when the up arrow is moved, I want it to move. And then when the down arrow, I want it to stop. So right now, if I hit forward, oh, it's moving, but it's not moving where I want it to move. All right, so I've got some challenges that someone would have to work through. What's that?
You have to go back to 0.
I have to go back to 0. So there's all sorts of things we can play with this. I do want to share a few other features of the programming environment we have. We have down here the stage area. And if I click on that, it's just blank for now. But I can either draw my own stage or I can go ahead and choose from their library. And again, they have all sorts of different venues that you could choose from. You can even import your own graphics. Like say you have a scenic picture or a picture of a real life castle and you want to include that into your program, you can do that as well. And I can have multiple backdrops and change backdrops so it looks like they're going from scene to scene to scene. And that's really cool too. Someone may complain, Ed, your car is huge. Well, with my sprite selected, I can immediately change the size. I can shrink it. It's not shrinking very much. Why is it not shrinking? Oh, I click on the tool and then I have to click on it. I'm sorry. So I can click on this and it shrinks it. So there's my car, itty bitty. And if it's too big, or too small rather, I can make it grow. And I'm just clicking with my mouse to make it grow each time I click on it. There's also a stamp up there that allows me to duplicate it as well. We didn't get to sensing at all, but we can get it so our car identifies different colors. So on my backdrop, let's say I wanted to make a racetrack. So I'm going to grab my paintbrush here, and I want to use black as the color for my racetrack. I want to make that a little thinner. And let's just say this is the outline of my racetrack. So I've drawn my racetrack, and I need to have it inside here for my car to go around. And of course, we get a nice little smiley face. And I would want to fill that in too. So I'm going to go to fill and fill that in. I've missed one little corner piece here. All right, that little white dot hopefully doesn't cause me problems. I need to shrink my car down to fit on this track. But now I can work with students on how do we get this, once they get the movement algorithm down, how do I get this so that the car identifies when it collides with black, and how do we get it to do stuff? Under scripts, you can see over here, there's all kinds of different settings in here that we might be able to use. There's also control settings we can use. I like this one, when touching a color. So when it's touching black, then we know it's actually hitting the side. Maybe that slows the speed down. if we had the outside here pink and it ever touches pink, then maybe the car blows up or something. We can have different ways it interacts. We could also do digital storytelling. When somebody sees this Rapunzel's hair pulled down, fall down from a tower, and they go ahead and touch the hair, well, maybe they pull the hair so hard it has her fall out of the tower on top of them. We can change all our fairy tales around in this program. It's really cool. Are there questions that or things that you'd like to see before we end? Because we do only have about 5 minutes left. My hope today was to show you a little bit about how to get people used to that question and answer, the raise a hypothesis, test it, and then revise based on what you see. That style of learning is difficult for most of our adult learners who come in with us, but it does create a type of thinking that is much more resilient, so that when they're, let's say, trying to do some math problem someplace, you know how it is when it has more than one step. They immediately start freaking out and like, oh my gosh, this is such a long problem because it has 3 or 4 steps. Getting them programming like this and working through that cycle of what should be happening, what are you seeing happening, how do we adjust that? That helps them a lot with persistence, especially in their mathematical processing. Did you have any questions, Lacey?
Only right at the beginning when we tried to establish the cat at the center, where it always went back. In the programming, you put 0, 0, but the position of the cat wasn't 0, 0. It was X something and Y something. And I wondered how the program, I guess it identifies wherever you are as 0. Yeah, down there.
Yeah, let me get the cat back. Let me get the animals. Here's our cat. Let's put him in. So I've got the cat there, and I'm going to delete my stage here. So I want to right-click.
Right there, you can see, if you click on the cat,
yeah,
it says that it's at 20 or without.
I moved it. Sorry, let me get to the move so I can move to 0, 0. Go to 0, 0. Okay, let's move there. So there it is.
Okay, now on the XY at the bottom of the,
yes,
it says 240, and I can't read that old one.
Negative 61, I think. Yes. So what's going on with that? Oh, notice how that changes?
Yeah, it follows the mouse.
That's where my mouse is.
But if you put your mouse on the cat, it's not 0, 0. Oh, maybe it is.
See, I got to find the exact center. Yeah. But that difference you've just brought up, how this is my mouse setting, but up here is the actual image setting.
Oh, okay, I see it. Okay, thank you.
But this also gets back to the problem I was having with my car in terms of where is the center on this cat? Oh, it's way up here by the smile. I thought it was down by the belly.
Okay.
So I was aiming in the wrong spot. So just learning about costumes, how they're drawn, how they're centered, and how that can mess up things, that could be a big lesson as well. Thank you for bringing that up.
And thank you for the session. It's been great.
Well, this is a fun product, and I think there's so much support material out there for teachers to engage in this. If you have a student who is unsuccessful in mathematics, I highly encourage you to start getting them playing with this a little bit, and you'll be surprised how you can slip a math problem into this. They don't know they're working with variables. But when you have something called speed and you need to increase it when they go forward, they're working with variables. They're saying, take the speed value, add 10 to it to make it go faster or something like that.
And positive and negative numbers, and
positive and negative as well.
Means something and Y means something else in algebra. And
correct. And you know, I've worked with a lot of struggling math students, and their biggest concern is they're trying to focus on the procedures. And we'd love to have them memorize all those procedures and understand how they're used. But from a practical sense, they got to know what's a variable in the first place. How can I have a negative value? What does that mean? So these programs are really great in bringing that out. So if anyone has a suggestion for a future episode, please visit the Hanging with Education site. And if you don't remember where that is, that's here at 5squared.us. And it's Hanging with Education. There's a suggestion topics over here. I do have to caution that this is the last week that Google Hangout on Air is available to us. Google is stopping this particular service. So I now have to dive a little bit deeper into my geeky pocketbook here and figure out how to use YouTube Live or some other tool. So I suspect it's going to be, in some ways, easier for people to join because they simply will go to this website, they will go to the session, and there'll be a link right here that you'll click to join the event. The downside is I don't know that I can program the events so that you can do that ahead of time, or if you have to do it right then when the session starts. So I'll have to figure that out before Wednesday. If I don't, we may be skipping next Wednesday, and we might meet the Wednesday after if I need a little more time. And if anyone out there knows about recording live sessions to YouTube, please connect with me. I need a mentor. Otherwise, I wish me luck.
Great. Thank you.
Well, thank you for joining me, Lisi. It's always nice to have somebody live and there to ask questions. And I appreciate the other 3 viewers who are watching from the outside as well. Hopefully you were able to see some things in here that were cool. If you have any last questions, go ahead and whip those out. I'll try to address those. Otherwise, I wish you all a good evening, and we'll try to catch up with you next week. It might be a couple weeks. We'll see how that goes.
Thank you.
Have a good night.